Here we are, 7.4. You're in 7th grade. We're on the 4th lesson. Well, you're in 7th grade math. Here we go. Number lines, sequences. Some more terminology we're going to throw at you. A lot of this is really technically review, but great review to get in our minds because you're going to see this more and more. It's going to come up, so we want to know how all this stuff works. So first of all, we talk about number lines. Number lines, of course, can cover whole numbers, right? We talked about that idea a few lessons ago, starting at 0 going to infinity as long as it's a whole number, right? But now we want to bring in integers. Integers, of course, goes the opposite way, and we're going to throw in our negative numbers. However, in the end, we get this thing called an origin. Origin, of course, is our 0 spot, right? 0, 0, 0, 0, 0. Origin. Wonderful. And so we have this idea. We don't want to forget it. Moving on to new concepts. Maybe not new concepts, but different concepts, right? Of course, we have our tick marks. They're going to help us understand which numbers go in each spot. Next, as we look at integers now, right? Sometimes we just say numbers. Integers means all positive and negative numbers, right? But as we look at integers now, we can talk about, okay, integers brings in some new ideas of making sure we're ordering things correctly, right? So it says, okay, arrange these numbers in order from least to greatest. I don't know if I can do this. 0, 1, negative 2. Okay, well, 0 is an origin, so that should be there. All right, 1, that's a positive number, so that should be there. Oh, 2, that's a negative number. Oh, put a nice comma there. Beautiful. Wonderful. Great, great job. And we can check our work. Look at that, right? 0, negative 2, 1. Hey, I did it right. If you weren't sure how to do it, if you weren't sure how to get these in the right spots, get that number line out. Use it. It's a great tool. It's a great tool. Moving on. How about this idea? It says write the expression with the correct comparison symbol, right? So if we get those number lines, we can compare things. Oh, that's not a number line, right? If you need that number line, draw it, right? Okay, gotta get my number line out. Doot, doot, right? Origin, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's put my numbers on. Okay, positive 3, 1, 2, 3. That would be right here, negative 5. Let's see, 1, 2, 3, 4, 5. Which one's bigger? Oh, right, I know how to do that. But here we see it says write the expression with the correct comparison. It doesn't say just fill in the circle. It says write the entire expression, right? And so we're going to say, okay, well, that's negative 5 is less than 3. And so this is how this expression is truly written out. All right? And so we can say that. All right? And that's really our next point here. How do you say this in words? Write the words. Okay. Write the words. All right. So I'm starting with negative. And then 5. Okay, gotta use the word. Is. Right? Is like equals, right? But in this case, we don't really have an equal sign here. We have this symbol here, which means less than. Less than. Going over my box. And finally, the last word, of course, is 3. 3. Didn't make the video. It's just a 3. Kind of like that. 3. All right? Not bad. We understand it's 3. We get the concept. Moving on. Okay, now we want to visualize how to solve problems, integer type problems, on a number line. Okay, all right. So in any problem, we're going to start at the origin, right? We're going to say, okay, we're going to go positive 3. And so as we look at this, we're going to start by, right? Usually we kind of make some dotted lines going up that tick mark. Man, I am not in line. There we go. And we're going to go to 3, so we're going to stop right about there. So I'll draw a nice line. Okay. And then it says plus 2. Okay, plus 2 more. Plus 2 more. That's going to get me to 5. All right, so I went 3 the first time, went 2 the second time. And we can throw some labels in there to help us understand. Okay, 3, 2. Hey, that makes sense. 3 plus 2 does equal 5. Right? And that lines up with that mark right there. Not bad, right? And so we can say, okay, final answer, 5. Okay, all right. I'm getting it, Uh-oh, show this problem on a number line. 5 minus negative 3? All right. Okay, let's do it, right? We're going to go dot, 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 dot. We're going to come over here. All right, 5 is right here. Draw that line. Put a little label there. Okay, there's our 5. But now it says minus 3, right? When working in a number line, that minus sign says go the other direction, okay? All right, go the other direction. So I'm going to start here, and I'll go this way, right? 1, 2, 3. Right, I'm going to end here, so here's my 3, and that gives me a final answer of 2. Oh yeah, that's right. Yeah, 5 minus 3 is 2. That makes sense. But we're drawing these expressions to help us understand what is going on, right? Uh-oh, you got to do this one. Pause the video, draw your number line, solve 3 minus 5. Oh, you thought that was in the lesson. It's not, right? This is 7th grade math. We're going to throw concepts at you until we get to the truly new stuff. Now, this one is a little bit new, right? As we look at this concept, we see 376 minus 840. As we look at this number, or this expression, we say, how do I solve this? Well, the first thing is we know we're taking, right, this is the smaller number, this is the larger number, and we're subtracting. So in the end, we're going to come away with a negative number. Now that we know that it's a negative number, we got to remember to add that label. But what we can do here is I can take this 840 and subtract the 367 like that to be able to do this. And I'm going to get a negative, and then just make sure I put a negative number because I know that this number is bigger, right? Oh, I already drew it out. Man, I had to write it twice, okay? We can do this because of our number line concept, right? I could make a giant number line with every single dash mark, you know, start from 0, right? And I'm gonna go to 376, right? And then I'm gonna go back this way, right? 840. Right? But when we look at that, look, we're cutting out this chunk of 376. The difference is as we've already discovered, right, it's way over here in the negative. So if we solidify our negative, right, so we're going to put that out there, it's going to be a negative. 0 minus 6, oh, can't do that. Cross it out, that becomes a 3, that becomes a 10, now we got a 4. Okay, 3 minus, oh, I can't do that. That looks like a B. Let's cross that out and make it a 13. 13 minus 7, 6, 7, 4, 464. But it's a negative 464. Oh, I don't like that negative so far. Okay, scoot him in closer. Now he belongs. Now he's happy. He's friendly. All right. It looks a little strange, but it definitely makes the math a whole lot easier because can you imagine taking 376 minus 840? Because to do that, okay, that's easy. That's easy. How do you take 3 minus 8? There's nothing to borrow. And that's why we can do this. We can actually reverse this. We know it's going to be the right answer because of this concept with the number line. We're taking this idea of 140 and 840 and subtracting that 376. And that number line expression allows us to see that as long as we remember to throw in that negative in the end. We're not done. Sequences. Arithmetic sequences. Arithmetic sequences have a tendency to deal with things like addition and subtraction. So I'm going to throw a plus sign. I'm going to throw a minus sign up there. And they have that equal spaced pattern, right? So if I look at this, 0, 2, 4, 6, I could ask you to do a couple things. First of all, I could say, what is the pattern? And you'd probably say, looks like +2, right? Because there's an equal spacing of 2 every single time. And then I could even say, okay, what is, right, this is the first term, second term, third term, fourth term. What's the 8th term? Well, let's see, the 5th term would be 8, the 6th term would be 10, the 7th term would be 12, the 8th term would be 14. Yeah! Congratulations, you did a nice job. All right, geometric works in a slightly different way. Geometric is going to move in a pattern form, but not necessarily evenly spaced, right? So in this case, we're doing a little bit of multiplication, right? I'm taking this number, first number, and I'm multiplying by, do you see it? How do I get 1 to 2? Okay, 2, right, times 2. And then I take this number, and I also multiply that by 2. And then I take this number, and I also multiply that by 2. And that's how it keeps growing, right? But if I looked at a number line like that, that's 1, right? And then 2, and then 4, and then 8, and then 6. And the next one, 16, is going to be, it's not even on the screen, right? And it's not even spacing anymore, right? It gets bigger and bigger and bigger, and that's what makes it a geometric type sequence, right? And so if I were to ask for this, I'm just going to go 7th term, right? 5th term, of course, is going to be 16, multiplied by 2. 6th term is going to be 32, and so 7th term, right? 2 times 32 is going to be 64. Nice work. There we go. Moving on. So what about this sequence? Here's your sample. Half sample, I'm going to call it. Sample, can you figure out what is the next 3 terms in this sequence right here? All right? But don't shut off the video when you're done with that. There's a little bit more. Pause now, find the next 3 terms in the sequence. You thought I was going to give you the answer. Maybe, maybe not. Maybe you actually paused the video and solved it like I asked you to. And I'm not going to give you the answer. However, you may have noticed that this is neither a arithmetic nor a geometric type pattern. It doesn't follow either of them, and that's okay. All right? So there are other types of sequences out there. However, with any type of sequence, we have what's known as formulating them. Is we can recognize the pattern, because that's what a sequence is. It's a patterned list of numbers. We can recognize the pattern, and we can formulate it. And when we formulate it, we use variables to basically write a rule for a sequence. For example, as you look at this, right, we have formulas, and it says k equals n times n. What does that mean? K stands for the next term. N means to get the next term, I'm going to take the number and multiply by itself. All right? Multiply by itself. Does that work? Does that make sense? It seems to. But is it right? As we think about these things, you might say, what is going on? See, our pattern is this. To get my first number, it's 1 times 1. To get my second number, it's 2 times 2. To get my third number, it's 3 times 3. To get my fourth number, it's 4 times 4. That's our pattern. And so now we formulated that, right? Each term, right? The first term is n times n. If n is 1, then this is also 1. I get 1. And so I'm able to formulate that and recognize the pattern of that sequence, right? This is going to be the number, the next number, right? N times n. And so we have that idea. All right, it's your turn. One last sample. Work through this sample to solve this set of sequences. The rule of a certain sequence is k equals 2n. Find the first 4 terms, right? So the first thing you're going to do is plug in 1, then you're going to plug in 2, then you're going to plug in 3, then you're going to plug in 4. And that gives you your 4 sequences. Oh, you gave away the challenge of it all. That's okay. You can do it. You can do it. That's it. 7.4. Here we go.